So I'm assuming by now you have your antiderivative. Is that correct in saying that? All right. Lottie, what do you got for your first term of the antiderivative? Say that one more time. Close. So you raise the power by 1, and what do you do with that power? Divide it. So you do 1/8 divided by 3, which is not 3/8, because that would be multiplied. 1/24. Yeah, so just make sure you remember. You know the rule. You just got to make sure you do it correctly. And then the plus 1, JP, what do you get for your term for the plus 1? Plus x. So there is my actual antiderivative, step 1. Ramsey, what do you get? Did I give you enough time to get f of 4? What'd you get? That is correct. 20/3 is correct. Alright, let's see. F of 0, Annie, easy one. 0. Alright, so what is our actual just kidding, our integral? I was about to say antiderivative. Integral is 20/3. So I don't want to see the major mistake, which is you see that and then you skip this. Therefore, you just substitute into there. That's the only mistake I really see. Okay? You got to find antiderivative, f of b minus f of a. So that's FTC2. All right, so you get this guy. So I'm going to review how to do RAMs. And here's a really odd thing. I actually want you to ignore the graph. I don't want you to graph your RAM first. I want you to be able to take a function, not have to graph it, and still be able to write out the notation of the RAM. And what I mean by notation is I'm going to assume we can type that into the calculator and get our actual numbers. I want to see the notation. So if you're going to use the height at 2, I want you to use y of 2. If you're going to use the height at 4, I want you to use y of 4. And I'd like you to write the notation of the LRAM. Okay? After you're done that, then you can draw your actual LRAM. Alright, so in this case, you want 4 subintervals, and if they don't say it, it means you want consistent intervals. So how wide is a subinterval? 1. So this is a really easy one, 0 to 4. That makes it very easy, but some of you struggle when if it was 0 to 0.5, and I still want 4 subintervals. So make sure that you understand. I think one of the ways was to visually break it up. I said draw 4 lines and see what that does. Most of you can figure it out just by using that. The other option you have is b minus a over n. B is 4, a is 0, n being 4 subintervals. So that works too. Thanks, guys. Thank you. All right. So they checked it yesterday. So you end up with common width of 1 multiplied by, if I'm doing an LRAM, which is the only y value that I do not use, 4. So the LRAM doesn't use this right side because it's a left side. So you start from the left. There's 1, 2, 3, 4 rectangles starting from the left. So you just want to make sure you started from y of 0, y of 1, y of 2, and y of 3. So then I'm just asked you to go ahead and graph it in case one of the problems is to graph an LRAM. You want to make sure you can do that too. I would say that if you had trouble, most of you had trouble doing inscribed and circumscribed, inside and outside, or M's, middles. Okay, so there's my LRAM. Then I asked you to do your RRAM. Same concept. We already know the common width. Common width was 1. And then same thing. I'm using the values 0, 1, 2, 3, 4. If you're doing a right side, then you're going to skip the 0, and you'll do 4 of them to the right. 1, 2, 3, 4. So you end up with y of 1 plus y of 2 plus y of 3 and plus y of 4. And if you remember the reason why this works, these are the heights of your rectangles. And then if I asked you to draw your RAM, should look something like this guy. Okay? So any questions on building an L and an R? Okay? The reason why we were able to take the shortcut for all of these, common. We had a common width for all of them. So then now we're going to do a trapezoidal. Trapezoidal is a little bit different because we're going to build trapezoids. So there's my graph. I want to go through the area of a trapezoid and make sure you understand that formula. So the formula is given 2 different ways. The first formula is where you'll hear people say the area of a trapezoid is the average of the bases Average, add them, divide by how many? So 2. And then multiply by the height. So that's actually the formula for area of a trapezoid. I write it differently. I like putting h over 2. It just gives me one less thing, one less set of parentheses. So this is actually the one that I use more commonly than that one. Okay, but they mean the same exact thing. So then the other thing is, what are the bases? So what's the definition of a trapezoid? It has exactly one pair of parallel lines. So most of you are probably used to seeing, things like this as trapezoids. Yeah, right? So this is the base and this is the base. So the definition of a trapezoid is that the bases are the parallel lines. Always. Okay? Meaning, if I have that being the base, and the height is the perpendicular distance between the two. So, problem is, when we draw our trapezoids, they're not going to look like that. They're going to be sitting on their sides, and they're going to go up. So now, since these are the parallel lines, this side would be a base, this side would be a base, and the perpendicular distance between the two is now the height. So the trapezoids that you're going to build, they're going to be laying down on their height and not really on the base. That does confuse people sometimes. So now we're going to draw them. So how do you draw them? You're going to go to the fact that we know already that we have 4 of them. We already know that the common width was 1. It's the same thing for a trapezoid. So my trapezoid, the way we build them, you take your first subinterval, go up to the y values, and build your 2 points. Then you just connect them. So I'm going to connect from one to the other, and there's my first trapezoid. Okay? So then I'm going to do the second one. I'm going to go back to 1, I'm going to go up to 2, and then connect them. The third one in orange, I'm going to do 1 at 2, 1 at 3, and connect. And then the very last one, which I guess I'll do in blue, will be at 3, all the way to 4, connect, and there are my 4 trapezoids. Where are all the parallel lines? They're running up and down, which is why I'm telling you that it's laying down on its side. So, for every single one of them, we're going to actually write out the notation instead of the actual value. I assume you can just throw that into a calculator or into the function itself. So, your very first trapezoid would be this guy. We're going to use the height over 2. Okay? So this is considered the height. This is base 1, and this is base 2 for the red trapezoid. So my height is 1 over 2. My base 1 is y of 0. And my base 2 is y of 1. So there's my red one. My purple guy, now I have base 2. Oh no, just kidding, base 1. I was lying. Base 2 and my height. The height is 1. My base 1 is y of 1. My base 2 is y of 2. Next one looks like it's in orange. Base 1. Base 2, height, so height, and then base 1 being y of 2, see, y of 3 being the second base, and then the very last one in blue, base 1, base 2, 1/2 with my height, y of 3 plus y of 4. Ooh. See if I can get that 4 in there. There we go. So there they all are. Every single trapezoid. Kind of a pain, because there's a lot of them. So now we're going to notice patterns. Okay? Give me 1 second, Joshua. Okay? What's the pattern? What do you notice that they all have? 1/2. So where did the 1/2 come from? Well, obviously formula has a 2. And then the height was a common height for all of them. So I just want to make sure that you know that that's the height, which is exactly the same as that common width when we talk about rams. So that's the same thing up there. All right, so let's see what else we notice. Anything else? Anything else that might be helpful for us to know when doing these? Joshua, what do you think? Uh-huh. Okay. I noticed that too. Yep, Anthony? Joshua said first that there's double of the y2s, 3s, and 1s, and then Anthony, you're giving me that it looks more accurate. Those are definitely the 3 things that I notice. I notice number 1, that they all have the 1/2. I notice that there's double of the y1, 2, and 3, and then I also notice that it looks way better than my L and my R. 3 major things. So let's first talk about the formula down here, and then we'll talk about the accuracy. So I'm going to steal from here to the next page so that I have the formula written out. Oopsie, that thing's going to be in my way. There we go. What was I doing? Taking this. Oh, that was not what I wanted either. Wow. Try it one last time. There we go. Alright, so on the next page, I'm going to write out what we had. You guys have a little space at the bottom. I obviously used up all of mine. So there it is. So now we're just going to write it out the most simplified way we possibly could. So we already just said a second ago we're going to take out that common term, which was the 1/2. And then inside I would have a y of 0, which I did not double. But then now I have double of the y1. I have double of the y2, and I have double of the y3, but then at the end, I don't double the y4. Did I write that right? Oh, I wrote them kind of differently. I'm sorry about the notation. I'll fix that. So, for each of them, I want to understand if that would always happen, or is that just by chance, this picture did it? This graph, this function is the only one that would happen with. So let's go back and look at it. So there's my graph. There's my trapezoids. Would that always happen? Yeah. So you'll notice that they share a side. They share a side. They share a side. And the first and the last don't share. Okay? When you did an LRAM, which value did we not use? What X value did we not want to use for an LRAM? We didn't use the maximum, the last one, the right side one we didn't use because we're doing an LRAM. And in RRAM, we didn't use the left side, the very first. Trapezoidal, what do you notice? You use all of them, okay? So, shortcut is here. There's your shortcut. This one is with the other formula. Here's the formula that I use more commonly, is this guy. So you memorize the shortcut, and then how could you get a problem seriously wrong by using the shortcut? Anyone know? Hand up if you think you might know. Nathan, what do you think? If the width isn't constant. That's the only major catch, and you guys know that across the board. The major catch is you never check for the common, and you just do the common for everything. So let's make sure we remember. Put H has to be a common width. And I'm using the word width because you're probably more used to calling that a width. And then at the bottom, you're going to put a big old star, whatever that might be, something huge. Only works with common widths. Okay, that's the only thing you're allowed to use it for. So you hope you get common widths because they're much nicer, much quicker. Okay? Let's do a little bit of practice, and then if there's time left over at the end of class, I'll ask if you have any questions from homework, okay? So, oh, just kidding, not practice. Yeah, I forgot. We got to do over and under approximations first. So, start out with draw a concave up curve. Sure. Oh, when I get a pen working. Draw a concave up curve. Draw a concave down curve. Gotcha. And obviously we're going to do a trapezoid. So I'm going to build a trapezoid in there. I don't care how big it is. I don't care how small it is. If it's a rule, it'll work all the time, no matter how big the trapezoid is or how small it is. So build a big one. Let's do to here. Huge one. Okay, so that's what the trapezoid, the very top of the trapezoid would look like. And let's build one over here. I don't care where you build it. Because if it's a rule, it will work even if the trapezoids are itty bitty 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 tiny guys. It's just way obvious if you make them big so that you can tell if you're right or wrong. So what do you notice? Draw your trapezoid, okay? You can build more of them if you don't believe me. You can build little ones if you don't believe me. But what do we notice? Well, over approximation, so my trapezoid has to be over the curve. When does that happen? Concave up. So my red trapezoid is above the blue curve. So concave up. Okay? So concave up is when my second derivative is greater than 0. And then obviously your under approximation, my trapezoid is under the curve, is when it's concave down. And I should say that I will never accept the reasoning of it's an under approximation because the trapezoid is under the curve. I will never accept that. That's not considered calculus based. Calculus based says it's an under approximation because f double prime is less than 0, or f of x is concave down. I won't accept it looks like it's less, or it's underneath, or the value I got is less than the real one because I checked it. None of those will work. You have to actually give this type of reasoning, concave up, concave down, which gets confusing because we've done over and under approximations 3 other times. We did it for linearization, LRAM, RRAM. So this is actually the 4th time we've talked about over and under, which gets confusing. So I have a little table underneath to try to help you remember which ones they were, and then we'll do a quick little picture to help guide your memory. So you have to know it for 4 different types. We do over and unders for LRAM, RRAM, trapezoidal, and then don't forget the little linearization. That's actually the first time you ever heard it. Okay? So your LRAM, we have over and under. You should remember the basic rule of increasing, decreasing is what these two work with. So I'm going to draw a increasing curve. I only draw one, and I do an LRAM to it. So that's the left side of my rectangle. So just with that, is that enough for me to know the rule? Yeah. So if the function increases, then I know the LRAM is what type? It's an under approximation because the rectangle definitely looks like it's underneath that red curve. So here would be when the function increases. The LRAM would be an over approximation when it decreases. If you don't believe me, draw a decreasing curve, draw an LRAM. It's definitely going to be underneath. Or sorry, over. All right, next one, RRAM. So I do the same exact thing. I'm going to just draw an increasing curve and one rectangle that's to the right. Just one. That's enough for me to know. So now I know over approximation happens when the function increases. Obviously then, this one has to be decreasing. Pretty much the way you get it wrong, you think it's concavity and you deal with concave up and concave down. I do pictures for a reason because you're verifying that it works. So let me show you one that doesn't work. Maybe you thought that these were with concave up. So go ahead and draw an LRAM. So here's an LRAM. And you say, oh, it's going to be an over approximation till I get over here. And what happens now? Now it's an under. There's no rule. You just negated your rule. That tells you concavity can't be the rule for LRAMs and RRAMs. Okay, linearization, that's the one that's kind of like trapezoidal. We do concave up and concave down. So let's just do a concave up. Draw one tangent line. And then that's enough for me to know. So linearization, concave up, the tangent line here is under the curve. So this one over here has to be concave up. Therefore, this one must be concave down. And then if you don't believe me, draw it, check it. Okay? So there's 4 different ways you have to know that. But what Anthony said before, if you had to choose the most accurate, which one would you choose? Trapezoidal. Okay? So you do trapezoidal when you're trying to get an approximate value that's close to the real. Your L and R's are pretty far off unless you make them extra, extra, extra tiny. Okay. Now we can get to some practice. So this guy, use the trapezoidal rule with n equal to 4 to approximate the value of the integral. I'm going to allow you to use function notation, so you're allowed to use y of 1, y of 2, y of 3. You don't have to find the exact value. Go ahead. Write your notation. Yes. Let's see. All right, so let's see. I'm just going to write out the formula for the area of a trapezoid, just so I have it. Okay. That's my formula. I'm going to go over here, I'm going to look at n equal to 4, and I am going to decide, number 1, how wide my intervals are. So you're going from 0 to pi, n equal to 4. I see some of you using this formula, which works. That gives you your delta x, which is your width of your interval. The rest of you probably figured out it's pi wide, you want 4 of them, pi over 4, I would hope. Okay? So, pi over 4 is my h. So now that I have my h, here's the piece that most people forget. You just write pi over 4 and then you start moving on and get started. What did you forget? Dividing by 2. So if it's a fraction on top of a fraction, then don't write the divided by 2. Multiply it by what instead? 1/2. Okay? So that's the same thing. Alright, so now we got that, and I'm going to do my trapezoidal, which means I'm going to start with my very first height, and then inside in the middle, because these are common widths, I get to do double of my y of pi over 4. I'm going to do double of my y of pi over 2, which is 2 pi over 4. And then the last one is 3 pi over 4. Because then after that, I'm not going to do double anymore. I'm going to do the very last one, singular. So that would be pi over 8 multiplied by those values, which we could easily find because those are all in the unit circle. Yes? Thank you. Thank you. Thank you very much. All right, awesome. Letter A done. Letter B. All right, use the concavity to predict whether or not. So obviously I helped you out with that instead of just asking, is it over or under? So sine of x. So the reason I do this problem is because you hear f double prime, people think they have to find f double prime and do a sign chart and check if it's a plus or a minus. That works, completely works, but if you can graph the function, you can use the graph of it. So meaning, do I know how to draw sine of x? Yeah. So there's 2 pi, there's pi, and there's pi over 2s. I know that this is what the full sine function looks like, but we only care about from 0 to pi. Therefore, the whole entire 0 to pi is concave down, which means that the trapezoid is which one then? Over or under? Under. And if you don't know, draw one. Doesn't have to be the exact one. Just draw one in there. That is definitely an under. If it's a rule, whether I draw one trapezoid or I draw all 4 of them, the rule will work either way. Doesn't matter how many, because it's a rule. Does that make sense to you guys? Why I'm not drawing the exact trapezoid? Okay? Those are just my little ways to remember things, because I don't have a very good memory. Seems like I do, but I don't. All right, find the integral's exact value. I'm going to skip that. If we have time, I'll come back, but I want to do this guy. I want to talk about this dude right here. Example with a table. I always like the tables because if you notice in your tables, the ones that I do in class, they all go vertical. So what do I do on your test? I make it horizontal. And wow, does that just blow your minds. I don't know why, but it does. So whether or not the table goes vertical or horizontal, if you understand the concept, it won't matter. So what do you notice about the table right away? They're not common. So this problem, it sucks. It's a long problem. Why? Because you're going to have to do, how many intervals did they say to do? 6. You're going to have to do that 6 times and then add them all up. That's what not common intervals does. It makes the problem a pain. So let's just make 2 just to make sure you understand how to make them. So this is what most people do. They do a little bracket here and a little bracket here. And they remember me making brackets, and that's what they do. Why is that helpful? Because what are you supposed to use it for? These are always your widths. These are always your heights for rectangles. But now we're doing trapezoids, so it does get a little confusing. These are your common heights, and these are your bases. So this is the height. These are your bases. So the height of my very first trapezoid goes from 0 to 0.5. How wide is that first trapezoid? Or how high is it? 0.5. Why would I want to do this? Because that tells me that the very first one is my base 1, and the very second one is my base 2. So my first trapezoid would be h over 2 times y of 0 plus y of 0.5. There's no 2 in here, because I'm doing them all one by one. Then I'm going to do one more real quick for your notes, and then I'll stop there. So this would now be 0.7, and this would be my base 1 for my purple and base 2 for my purple. So I get 0.7 over 2, 675 plus 720, and in case you're confused, you would be adding all 6. Oh my god, yeah, that is supposed to be 675. Thank you. Craziness. I wrote it there, didn't write it there. So thank you, David. If they give you the values, I usually write them in, but yeah, you would actually be fine to not write them in, but then your final answer would obviously have to be a decimal or the actual value using them. Okay? All right, we good?